All right, so when we're talking about parallel lines cut by a transversal, we first have to identify, well, some vocabulary parts, right? Parallel. What does it mean for lines to be parallel?
They never intersect.
And they have to be in the same plane, right? The same plane. Because skew lines are also lines that never intersect, but they are not in the same plane, right? So we're not talking about skew lines. We're talking about coplanar ones. So parallel lines are those that don't intersect. Now, algebraically speaking, what does that mean for them to be parallel?
Same length.
Not same length. These are lines that go on forever. Infinite length, so it's got nothing to do with length. Same slope. These lines have the same slope. The exact same slope. If they're parallel, then their rise over run is the exact same, right? Their steps. Their steps are the exact same. That's how we know they're parallel, based upon their slope. So if you have a linear equation, the slope is a number in front of x in your linear equation, your y equals mx plus b. Okay, it's the m part that tells you the slope if they are parallel. Okay, which is fantastic. Now, if we were in the real world, right, the real world, quote unquote, we would measure. Is this 5 feet apart? Is this 5 feet apart still? Right, that's how you would find if something is parallel in life. You would measure it. You get out a ruler or a tape measure, and you would actually measure, right? If you're in construction, and if you want to make sure that your hallways are parallel, you measure the front part and you measure the back part, and you make sure that they are the same. Or your hallways are going to come to a point at some point which is not good. Okay, so that's fantastic. But let's talk about the geometry. In geometry, we're going to mark these, right? Things have markings. Well, we'll mark parallel lines with triangles or with angle things. So the markings here, these arrows or these triangles, can go either direction, left or right. But if you have them, then that means geometrically that these lines are parallel. So it's important to look at the markings to see if they are actually parallel. Because if they're parallel, then certain algebraic relationships exist. And if they're not parallel, then they don't. So there are your parallel lines. Now there's a thing called a transversal. Now I don't want to draw that one here. Let's draw this one. Transversal. Okay, that's what this is called. The transversal is a line that intersects both of your other lines, right? It transverses, transports, right, to carry across, or transform, to make into a new thing. You're crossing things. Okay, so this is your parallel lines, and this is your transversal. Now, when parallel lines are cut by a transversal, we make 8 different angles, right? 1, 2, 3, 4. There are 4 sets here. And then there are 4 angles down here, 5, 6, 7, 8. Okay, there are 8 angles that are created when parallel lines are cut by a transversal. Okay, and from these 8 angles, we're going to have our 5 vocabulary words based upon the positioning. Okay, like angles 1 and 5, or angles 4 and 6, or angles 2 and 7. Right? They all have a name. And when they are parallel, they have an algebraic relationship. Okay, and that's what we're going to talk about today. So looking at this piece of paper here, this worksheet, this is our parallel line. Notice it has a triangle here. And this is our other parallel line, which means this line is your transversal. So we have a parallel lines cut by a transversal, and those are your 8 angles that are created, okay? So there are 5 different types of angles, 5 named angles. In other words, we're going to classify these angle names, okay? And there are 5 of them, and they are like this. So here are the 5 types. And remember, angles goes after all of these words. So corresponding angles, alternate interior angles, alternate exterior angles, consecutive interior angles, and consecutive exterior angles, right? These are all angles that are formed when parallel lines are cut by a transversal. So let's look at some examples and see if you can put in that part for positioning, right? Because you're the ones that have to understand how they're positioned. When you see them, you should recognize them. Okay, so some corresponding angles. There are a whole bunch, but for example, angle 1 and angle 3 are some corresponding angles. Angle 1 and 3 are corresponding angles. Angles 8 and 6 are corresponding angles. Angles 8 and angle 6 are corresponding angles. Okay. Also, angle 2 and angle 4 are corresponding angles. And then the last set would be angle 7 and angle 5 are corresponding angles. Now, of course, begging the question means using the word in the definition of the word, right? So if you want to say that corresponding angles are in a corresponding position, right, that doesn't really tell you a whole heck of a lot, right? That is how you beg the question, is that you use the word in the definition of the word. Okay, it's kind of like describing the taste of salt. It is salty. Yeah, no kidding. That's what salt is. It doesn't tell me really anything about it if I've never tasted salt before. So corresponding, how are we going to describe the position of corresponding angles? Okay, so corresponding angles are congruent. That is their algebraic relationship. They are equal in measure. Okay, so if angle 1 is 120, that means angle 3 will also be 120. Corresponding angles are congruent. Okay. Some examples would be angle 2 and angle 6. Angle 2 and angle 6 would be a pair of alternate interior angles.
Would 8 and 4 be one?
And also angle 7 and angle 3. Okay, now these are the only ones that are alternate interior angles. So let's look at their positioning. Alternate, what does it mean to alternate?
Different sides.
To be on opposite sides of your transversal, right? The opposite sides of your transversal. 2 is on the right side, 6 is on the left. 7's on the left side, 3 is on the right. And they are interior. Interior to what? Your parallel lines. So these are between your parallel lines. It has to be between your parallel lines or they are not interior. Right? So here are all these angles are interior to your parallel lines because they are between your parallel lines, right? Interior means between. Okay? And the relationship, the algebraic relationship is they are also congruent, having the same measure, having equal measure. So 2 and 6 or angles 3 and 7 are alternate interior angles. Okay, so if those are alternate interior, where do you think the exterior are?
Outside.
On the outside of your parallel lines. Exterior. So how about some examples of exterior angles?
1 and 4.
Angles 1 and 5, as well as 8 and 4. Perfect. I heard both of them excellently. Well done. 8 and 4 and 1 and 5. Okay, alternate exterior on opposite sides of your transversal and outside of your parallel lines. Right? Exterior to your parallel lines. Okay, and these guys are also congruent. And we will be doing a proof of this a little bit later, but today just believe me that they are congruent.
It's inside.
Let's talk about the consecutive interior ones. Their positioning is inside, so they have to be between your parallel lines still, so between, and consecutive on the same side of your transversal. Excellent. Consecutive interior are the same side of your transversal and between your parallel lines. So what about angle 2? Which one is angle 2 consecutive with?
3.
Angle 3. Angle 2 and angle 3 are consecutive interior angles.
And 6 and 7.
And then the other ones, angle 6 and angle 7, would be your other pair of consecutive interior angles. So all of these angles come in pairs, right? We have to have two of them in order for it to be an angle pair. So how do you think angle 2 and angle 3 relate? Do they look like they're equal? No. So not congruent. What's the only other thing we do in geometry? Add them up to 180. So the vocabulary word is supplementary. These are supplementary. They add up to 180. These two lines add up to 180. These two angles, add up to 180. Angle 2 plus angle 3 adds up to 180, as well as angle 7 plus angle 6 adds up to 180. Okay, you can probably guess, but use your brain and talk about consecutive exterior angles. So they're outside of your parallel lines and on the same side of your transversal. So what would be some angles that are in that position?
1 and 4.
Angle 1 and angle 4, as well as
8 and 5.
angle 8 and angle 5. Excellent. And just like their interior friends, these ones are also supplementary. Supplementary angles. Okay, so still the same side of your transversal, but they're outside of your parallel lines. Consecutive exterior. So 3 of these angles are equal to each other, right? The corresponding and the alternate pairs are all congruent, having the same measure. And then your consecutive ones are supplementary. They are the ones that add up to 180. So in this exercise, we have just trying to identify these angles based upon our picture over here. So angle 3 and 6 are both between your parallel lines and are on the same side of their transversal. So these are consecutive interior angles. Okay, angle 4 and angle 8. So here's angle 4. Here's angle 8. Corresponding. They're on the same side of your transversal, but on opposite sides of your parallel, right? Angle 4 is interior and angle 8 is exterior. So that's how we're going to know these are corresponding angles. They're on the same side of your transversal, but on opposite sides of your parallel lines, right? Not both interior, not both exterior. One is interior, one is exterior. Okay, 6 and 4.
Alternate interior.
Alternate interior. So if you trace these angles, they form the letter Z sometimes. So here's angle 4 and angle 6. These are alternate. They're on opposite sides of your transversal, and they're both between your parallel lines. So alternate interior angles. And then the last one, angle 1 and angle 7. Angle 1 is here. Angle 7 is there. These are alternate exterior angles because they're on opposite sides of your parallel or your transversal, and they're both outside. So alternate exterior angles. Being able to identify or classify the angles is the first step to getting the algebra correct. Okay, because now that you know what they are, we know that they either add up to 180 or you set them equal. So let's look at, we know in this case some algebra here. The measure of angle 1 is 100. So 1 is 100. Okay, so without even looking at the problems, let's figure out all these other things. What about angle 2?
80.
Is 80, because what is the angle name or classification between angle 1 and angle 2? These are called a linear pair. There are two angles that are adjacent, so they share your transversal, and they form a straight line. Okay, we don't get to lose the stuff we had 2 weeks ago. We still have linear pairs, and we still have vertical angles. We still have those things. They don't just magically disappear now. So looking at the other ones, what about angle 4?
Angle 4 is 80.
80 degrees, right? Because angle 1 and angle 4 are a linear pair also. And it is vertical to angle 2. So 80 and 80, of course, because they're across from each other. Angle 3 has to be 100 because it's vertical to angle 1. Okay, and it's linear to both of the two 80s, so they have to be the same. Okay, now where do we want to go?
That's, wait.
How about angle 6? What's angle 6?
80.
Is 80 degrees, right? It is corresponding to angle 2, so they have to be the same, and it's consecutive with angle 3. So those have to add up to 180, right? So no matter how you slice it, the math here is either going to be equal or adding up to 180. So hopefully you're able to fill out all 8 of those angles if you're just given one measure. Okay, because either they're vertical angles and they're equal, or they're consecutive angles and they're equal, or they're corresponding angles, and right? So now you can just fill in the blanks with all the ones that they want you to fill in. Okay? So the last step, and probably the hardest step, is the algebra stuff. So let's look at this problem and do some algebra. So the first thing we have is angle 1 and angle 4. So here are your picture, right? This is a new picture. Here's angle 1 and here's angle 4. So what type of angles, what is their classification for angle 1 and angle 4? Good. These are corresponding angles. So you're going to set them equal. So the equation 5x minus 5 equals 4x plus 20. Okay? If they're in a corresponding position, then the algebraic relationship is equal. Okay, so we identify them, right? We classify them according to their vocabulary term. And then based upon that vocabulary term, you do the algebraic relationship. So corresponding angles are equal. 5x minus 5 equals 4x plus 20. Right? So we're going to subtract the 4x over here, because we always try and do the x first. Move your x first. 5x minus 4x is 1x. And now we can add the 5 to the other side. 25. 20 plus 5 is 25. Okay, so x equals 25 for the first problem. Okay, the next question. What type of angles are angle 3 and angle 5?
Consecutive interior angles.
These, excellently well done. These are consecutive interior angles, or CIAs, consecutive interior angles.
So you add them
Okay?
together. And
So their relationship is they are
supplementary.
supplementary. So if we take the measure of angle 3, which is 14x plus 8, and add it to the measure of angle 5, 6x plus 12, that needs to equal 180. And there's the algebra that we're going to do to solve this equation for x. Okay, so today we're just solving for x, but remember in geometry we often want to find an angle measure. So if we were asked for the measure of angle 5, you would multiply 8 by 6, right? We would plug 8 back in and find an angle measure. Okay, so we'll be doing that in the future, but today it's just solving for x. Okay, number 9. What kind of angles are 2 and 5?
Alternate interiors.
Alternate interior angles. So the algebra says, set them equal. Alternate interior angles are congruent, so we set them equal. 3x plus 19 equals 4x minus 4. And there is the algebra for number 9. X equals 23. Okay, and then our last problem, angle 1 and angle 6 are alternate exterior angles. Very excellently well done. And how do alternate exterior angles relate? They set them equal, right? They are congruent angles. So we're going to take our 7x minus 25 and set it equal to 5x plus 13. Okay, that is our algebraic relationship. So we make this algebra so we can solve it. And that is the solution to our number 10. Okay, so when you run across one of these problems, the first thing you want to do is identify them. Are they corresponding? Are they interior? Are they exterior? Okay, once you identify them, do you set them equal or do you add them up to 180? Okay, those are our two things that we do with all of these problems when we have parallel lines cut by a transversal.